Kia ora Year 12 and 13. This is another identities task from the revision sheet that we've given you, and this is from task D. So we're going to look at this thing here. Let me just get the pen working. Right, so we want to prove that 2 sine of 2x plus pi on 3 plus 4 is equal to all of this. So as I've said in the task C video, when we do proofs, we can choose whether we go from the left-hand side to the right-hand side or the right-hand side to the left-hand side. So when I look at this one, I want you to make sure you've got a pen and paper so that you're working through it with me. I want you to jot down 2 things that you notice that you think might be useful in this proof before you get going. So do that now. Take a look and look for 2 things. Okay, so here are the 2 things that I see. I see this thing here is a 4 sine something cos something. And that makes me think of the double angle formula for sine. So that makes me think of this thing here, which is sine of 2x is equal to 2 sine x cos x. And when I look at this part of the expression, I can see something to do with that. So that's the first thing I notice. The next thing I see when I look at this identity is I see a cosec. And my immediate reaction is yuck. But then I remember that cosec of x is the reciprocal trig function for sine. So cosec of x is just 1 over sine x. And those 2 things are all I need to use. So in this case, what I'm going to do is I'm going to start on the right-hand side and I'm going to move through to the left-hand side. So again, I'd like you to pause the video and try doing that. Write out what's on the right-hand side and try to manipulate it as far as you can. On the next slide, I'm going to go through it. Okay, so here we go. We're trying to get to this point here. All right, so I'm writing this out again at the top because when we do proofs, we always have one eye on where we're going. Okay, so this is what we want. Now I'm just going to squeeze the cosec in here. I know that yours won't look this messy. I'm going off the page. There we go. X. So that's what we're after there. So we're starting on the right-hand side. So let's write that down. Right-hand side, what have we got? Well, we're going to expand it and get this. Remember, when you do a proof, you write out each little step so that your audience can follow easily the logic from one line to the next. So expanding this gives me that line there. Now the first thing I'm going to do is I'm going to use my knowledge of the relationship between sine and cosec. So they multiply together to give me 1 because the angle in here is the same. So that equals 4 sine of x plus pi on 6 times cos of x plus pi on 6. I'm going to write this out very fully, so it's going to be 4 sine x plus pi on 6, whoops, divided by sine of x plus pi on 6. Okay, and they simplify to give me 1, leaving me with this thing here. So if I treat this as my angle, what have I got? Well, I've got 2 times 2 sine x plus pi on 6 cos of x plus pi on 6 plus my 4, which gives me 2 sine 2x plus pi on 6 plus 4. Right, should be starting to get that happy trig proof feeling in my tummy. There we go, 2 sine 2x plus pi on 3. I'm just expanding out those brackets. Plus 4 as required. So we're done. Now you can try going the other way from left to right. It will work out fine as well. But I just found it easier to go right to left here. Thanks for watching. I will do the interesting question B, hopefully later on tonight, and then A.